So we need to compute the number of distinct solutions of this given equation, that is 5 over 4 times cos 2x squared plus cos x power 4 plus sin x power 4 plus cos x power 6 plus sin x power 6, that is equal to 2. So in the interval that is 0 to 2 pi. So first of all, if in case we are aware of this identity, that is cos x power 4 plus sin x power 4, so this can be expressed as 1 minus 2 times, that is cos square x times sin square x. Similarly, for this power 6, that is cos x power 6 plus sin x power 6, can be expressed as 1 minus 3 times sin x square times cos x square. Now, so first of all, I can just use the identity directly, but it will take some time to show you that how that identity can be obtained. So this very same expression can be written squared over here. So this is cos x square and again squared over here, sin x squared, and this is again squared over here. Now this can be written as, so this is in the format of a square plus b square. So that can be written as a plus b whole squared minus 2ab, right? So instead of a, I'll be writing cos x, that is cos x squared instead of a, right? And instead of b, sin x squared, and again this b sin x squared, and this cos x squared would be a. And from this we can clearly observe that if you observe this part, this is nothing but 1, and 1 squared is 1. So this is 1 minus 2 times cos x squared times sin x squared. Similarly, I'll just compute this part as well, that is the power of 6. Now here I'll be applying the identity. First of all, let me just bring it into the proper structure, that is power 2 here, and this is power 3 over here. Similarly here power 2, and then on this power of 3. So this is in the form of a cube plus b cube. So I'll be using the identity for a cube plus. So here a cube plus b cube identity I can use. So this would be a plus b times a square then plus b square minus ab. So I'll be using this particular identity. So instead of a, cos x squared, and instead of b, sin x squared, and that boils down to 1. And for this one, for this a squared, so this would be cos x squared, and on top of that power of 2. And for this we'll have this particular value, and a and b value is something that we are already having, that is cos x squared and then sin x squared, right? Now if you can observe this, I'll just replicate this. This can be written as 1, and this part is something that we have already computed here itself. So I'll just take this value and plug it over here. So I'll replace this with this identity, and this is clearly visible now, that this can be written as 1 minus 3 times cos x squared times sin x squared. So this part is handled. Now I'll proceed towards my equation. So this is the given equation. So let me just replicate this given equation as it is, and from here I'll start the simplification procedure. Now this part, that is power 4, this one I'll replace with this particular expression, that is 1 minus 2 times cos x squared times sin x squared. Similarly for this cos x power 6, so this one I'll replace it with this particular quantity. So again, if you observe this cos x power 6 and sin x power 6, this can be replaced in this way, right? Now if you can observe here, so here we are having -2 and -3, that is 5, and if you observe, this is +1 and again positive 1, so that is 2, right? So what I can do in this given equation, so here definitely the implication sign is mandatory. Now here this plus 1 and plus 1 is 2, so on subtracting 2 on both the sides, I'll be getting this, and this 2 and 3, this 2 and 3 merges to 5. So this is 5 times cos x squared times sin x squared. Let me just eliminate this term. Now, in order to get this term as common factor, that is 5 over 4, so what I'll do, I'll multiply 4 and divide this number by 4. So you can see that 5 over 4 is something that can be factored out. And interestingly, if you observe, you can clearly observe this identity getting applied over here. That is, this 4 can be written as 2 square. So this is clearly, if I take this entire expression can be written as, that is 2 times cos x times sin x, and this entire squared, I'll write the power 2 here, and this is nothing but sin 2x, right? So it is very clearly visible that this can be written as, sin 2x squared, and then 5 over 4 is the common factor. So in the next step, this 5 over 4 is the common factor, right? Yes. Now this is clearly cosine of 4x. Now from this step, we can just, instead of this expression, I can write cosine of 4x, right? And on multiplying 4 on both the sides, this would be 5 and this is 4. Sorry, that is again 0 divided by a finite number is 0, and again this 5 can be, that is, I can directly say that this 5 by 4, this real number, can be divided on both the sides, right? So effectively cosine of 4x is equal to 0. So finally this 4x, this particular argument 4x, this can be written in the form of 2n plus 1 times pi by 2, and from this, if I extract out this value of x, so this can be written as 8 over here, and from this we can say that n belongs to these are the numbers, right? That is 0, 1, 2, 3 and so on, all the way up to 7. And what is the reason behind that? The reason is very clear, that it is already mentioned here that 0 to 2 pi, the interval that is given to us is 0 to, so I'll write, because the interval is given as 0 to 2 pi, so that's why these are the acceptable values. So 0 through 7, so there are total 8 values that are acceptable for this. So finally we can say that our answer would be 8. So there are 8 such solutions. There are 8 uh, distinct number of solutions are there which will satisfy this equation within the interval, that is 0 to 2 pi. So hence this is the answer.